Hello, grade 10s. I'm going to be going through the 2019 Paper 2 June exam with you guys. Okay, so if we have a look at question 1, it's saying use your calculator to determine the following ratios, correct to 2 decimal places. Now guys, something like this you should be getting 100% for. So if we have a look at the first one, it's just saying sine 38. So just put that on your calculator, sine 38. Please make sure that your calculator is in degree mode before you do this. And then press equals, and they're asking us to round it off to 2 decimal places. So to 2 decimal places, this would be 0,62. Okay. The next one, they're asking for 2 cos 40 over 2. So we go 2 cos 40 over 2, okay, equals, round that off to 2 decimals, and we get 1.88. Right, the next one, we've got 4 tan 21 over 3. And to 2 decimals, that's going to be 0,51. All right, then the next question, solve for theta correct to 1 decimal place. So remember, if we're looking to find these angles, that is when we need to do our shift, whatever the trig function is. So in this case here, we would go shift cos 0,678. Please make sure it's got that -1 there when you're trying to find the angle. And we get, I just want to see, to 1 decimal place. So theta will be equal to 47,3 degrees. Okay. We go on to the next one. Always get your trig function on its own first. So you can see here we had the trig function on its own. Over here, we need to get that on its own first. So the first thing I'm going to do is take the 3 to the other side, and it becomes a negative, and we get sec theta equals 2. Okay. Now, the problem with sec, cot, and cosec is we don't have them on the calculator. We've only got sine, cos, and tan. So we need to change the sec. And remember, sec is 1 over cos. Theta equals 2. Okay. What I'm going to do now, grade 10s, because we want to solve for theta, all I do is invert this. Okay, so that will become cos theta equals, now just remember that this 2 is over an invisible 1. Now because I inverted that one to get this, I'm going to invert that, and we get a half. Okay, now I can do the shift trig function and the number. So here we'll get theta is equal to, and you just go shift cos 1 over 2, and we get 60 degrees. Okay. We have to get the trig function on its own. And now remember that this angle is part of the trig function. Okay, so don't do anything with this inside bit yet. So the first thing I need to do is to divide by 2, and we get sine 2 theta minus 60 is equal to, we divide that by 2, and we get 0.1. Okay, now this thing inside here is our angle. So just like what we did with these ones over here, finding the angle, I'm going to go shift sine, and then whatever's on this side here, 0.1, just to get the angle on its own. So that's what we did here to get that angle on its own and that one. So over here we get 2 theta minus 60 is equal to, then the shift sine 0.1, and we get, and I'm rounding it off to 1 decimal place, so that's 5.7. Now just remember that we're still trying to figure out what theta is. So I take the 60 to the other side, and it becomes a plus. So we get 2 theta is equal to 60 plus 5.7, and we get 65,7 degrees. Divide through by the 2 to get theta, and we get 32,9 degrees. Remember, to 1 decimal place, guys. And there's your answer for that one. All right, going on to question 2. Okay, question 2, they're saying for triangle ABC, determine the following: sine beta, or sine B rather. Now, if I look at the angle B, which is over here, that's angle B, I'm going to find the hypotenuse, adjacent, and opposite sides first. So this is always the hypotenuse, okay? It's opposite the 90. Then this side here, because it's opposite the angle that we know, it is opposite. And then this one here would be adjacent. So I just want to highlight that for the green angle. So sine B. Now remember your little sayings, silly old hens cackle and howl till old age. So silly old hen, so it's O over H. So this would be equal to O over H, which is AC over BC. AC over BC. Now we're looking at cos C. So here's our angle C. Now, pick out your hypotenuse first. So the hypotenuse is always opposite the 90. Then this side here will now be the opposite for this angle, and this would be our adjacent. Okay. So I just want to highlight that for our angle C. So now we're looking at cos C. So cos is silly old hand, cackle, and howl. So A over H. So from the red one, A over H. So that's AC over BC. Then we're still here with angle C. Now cot. Now just remember, cot is the reciprocal for tan. Okay. And if we want to look at tan, I don't know, of an angle, let's just say theta, tan would be silly old hands, cackle and howl till old age. Okay. Now remember, cot is the reciprocal for this. So the reciprocal just means you flip it. So this would be A over O. All right. So we're still over here. So our A would be AC over our O for the red one would be AB. Okay. Then sec B. Now just remember that sec is the reciprocal for cos. So cos of an angle, remember, silly old hens, cackle and howl. Cackle and howl, right? So A over H. So the reciprocal for that, which is sec, would be H over A. And we are with angle B. So H is BC for the green one, BC, over A for the green one is AB. Then tan B, remember tan is O over A. So O is AC over AB. And there it is, great tense. Right, so if we look at the next one, determine the size of angle B, which is this over here. So what I'm going to do is I'm just going to figure out what our OH and A is. So this would be the opposite, hypotenuse, and adjacent. Okay, so we want to figure out what size B is. Now, there's two ways we could do this. We could use trig functions, or as you can see here, we've got angles in a triangle. And I'm going to do it both ways so you guys can just see. So the first one I'm just going to say is that B is equal to 180 minus 90 minus 31,97. And the reason why is because it's angles in a triangle. That's 90, 31, 97, and we can work out what that is. So we get 180 minus 90 minus 31,97. And we get 58.03. I just want to see here in the front what it says we must round off to. Round off to 1 decimal. So if I had to round that off to 1 decimal, this would just be 58 degrees. Okay, so that's the one way of doing it. I'm going to show you another way. So we've got this A, H, and O, right? But the values that we know is the 9 and the 17. So what we can do is we can use our trig function. So which trig function has a combination of A, H? Well, it's cos. So we know that cos of that angle B will be equal to A over H, which is 9 over 17. Now you guys have seen with these previous questions over here how to find those angles. All I have to do is just go shift cos and then 9 over 17. And round that off to 1 decimal, we get angle B is equal to 58 degrees, which is exactly the same as what we got here. Okay. Then it goes on to say, determine the length of AC in 2 different ways. So we need to find AC, this one here, in 2 different ways. So the first way I'm going to do is I'm going to show you by Pythagoras, because we know what that is, we're missing this one, and we have a 90-degree triangle. So x squared plus y squared equals r squared. So what we're trying to find here is a length, okay? So that can be whatever. That can be our y and that can be our r. So x squared plus 9 squared equals 17 squared. All right, guys, so just like this in the calculator, just say 17 squared minus 9 squared, and we get that. Take the square root of that answer, and I'm going to round it off to 1 decimal place. So we get x is equal to 14,4, and is it centimeters? They haven't told us. Okay, so it's just units. All right, so that's one way of doing it. The second way I'm going to do it is, we know this angle, okay? And I'm going to work with this angle just because just now we made a mistake with our angle over here, okay? So I'm looking for a trig function that has this OH or even OA combination. I'm just going to go for the OH, okay? So, or this won't be OH for this angle here. For this angle, this would be AH because this is the adjacent side. So that would be cos. So here I know I have cos 31,97 is equal to the adjacent over the hypotenuse. So AC over 17. AC over 17. We want to get the AC on its own, so I just multiply up by the 17. So 17 times cos 31,97 equals AC. So AC is equal to 17 times cos 31,97. Round that off to 1 decimal place, and we get 14,4 units. Okay, and you can see it's the same as that one. All right, going on to the next question. It's telling us here, determine the length DC, this length over here. So what I need to do in order to find DC is I need to find this length BD first. Okay, once I've got BD, then I have an angle in this triangle. I'm missing a side, I can use trig ratios. So in this triangle over here, given this angle, 40, okay, that's 90. This would be the hypotenuse. This side here would be your opposite, and this would be your adjacent, okay, from the angle in green. Now we want to find that angle, or sorry, the size O, and we know what H is. So I'm looking for a trig function that has that combination OH, which is sine. So we know that sine would be opposite over hypotenuse, so it would be BD over BA equals sine 40, okay? We want to find BD, so I want to get that on its own. So BD is equal to BA, I'm just multiplying up by BA, times by sine 40. So BD is equal to BA is 21 times sine 40, and we get 21 times sine 40, and I'm rounding it off to one decimal, so we get BD is equal to 13,5. Okay, so now we know what this length is over here. We know that this is 13,5. Now I'm going to work in this triangle over here where we know what this angle is. Okay, so this is the hypotenuse, this is the opposite, and this is the adjacent for the red angle. Okay, and we want to find out what DC is. So we need the A, and obviously we need the O. That's the only length we know. So which trig function has that combination of OA? Well, it's tan. Okay, and we know that tan of 60 will be equal to the opposite, which is BD, over the adjacent, which is CD or DC. I want to know what DC is, so I'm going to get that on its own. Just multiply up by DC, multiplied by tan 60 equals BD. Then I divide through by the tan 60 to get the DC on its own, over tan 60. So we get DC is equal to our BD, we worked out here, to be 13,5 over tan 60. So 13.5 over tan 60. And round that off to one decimal place, we get DC is equal to 7,8 units. All right. Going on to the next question. Okay, Mr. Meagum is up a ladder against a brick wall. The foot of the ladder is 3 meters from the wall. So here's the foot of the wall to the ladder is 3 meters. The ladder reaches a height of 18 meters up the wall. So this height here is 18. Determine to the nearest degree the angle that the ladder makes with the wall. So what we want to do is we want to figure out what this angle is. Okay, the angle it makes with the wall. Now, as you can see here, it makes a triangle. So from the 90 degrees, this length here would be our hypotenuse. From here, this is our opposite, and this is our adjacent. So we are looking for the angle now, and we know what this length and what this length is. So which trig function has that combination of OA? It is tan. So we know that tan x will be equal to O over A, so that's 3 over 18. And then what we can do is we can just go shift tan to get the x on its own, and that's 3 over 18. And they want it to the nearest degree, so that would just be 9 degrees. Okay. Then it says, if Mr. Meagum slips and the foot of the ladder slides 2 meters back from where it was initially. So if it slips 2 meters back, so we call that 2 meters, it is now 5 meters away from the wall. And the angle between the ladder and the wall is now 23. So if I had to redraw this, okay, where that's 19, this is now going to be 5 meters. This angle here is now going to be 23. Determine how far down the ladder has slid. So what I'm going to do, grade 10s, is I'm going to work out what is this length over here. And now let's just say that that length comes to about there. What I can do then is I can take the 18 minus that length, and that will tell me how far it's fallen down. Okay, so to work out this length over here, just remember that this is your hypotenuse. From the angle that we know, this is the opposite, and that's the adjacent. Okay, so I want the adjacent. I know what the opposite is. So the trig function that has that OA combination is tan. So we know it's tan 23 will be equal to the opposite, which is 5 over, and I'm just going to say A. All right. Get A on its own. So we multiply up by A, multiply by tan 23 equals 5. Divide by tan 23 to get A on its own. Okay, so we get 5 over tan 23. And I just want to see here. Okay, so I'm going to round this off to 1 decimal. So it's A is equal to 11,8 meters. So now that means that this length over here is 11,8 meters, which is that length over there. Now, to find out the length that it slipped, what I'm going to do is take 18 minus the 11,8. And we get 18 minus 11,8, and we get 6,2 meters. So it slipped down 6,2 meters. All right, going on to question 3. State whether the following statements are true or false. If false, give a reason for your answer. The diagonals of a parallelogram intersect at 90. This is definitely false. The only time that it intersects at a 90 if it is a square, if it's a rhombus, or if it's a kite. Okay, those are the only ones that it'll be intersecting at 90. Then the long diagonal of a kite bisects the other diagonal, the smaller one. Yes, it does. That's true. Then the adjacent sides of a kite are parallel to each other. Well, that's definitely false. The adjacent sides are equal in length. So I'm just going to say adjacent sides equal in length. Okay. Then the diagonals of a rhombus bisect the vertex angles. Now, what they're talking about here, grade 10s, here's a rhombus. Okay, it's like a square, but it's just been skewed. They're saying, does that line there bisect this angle? And then does this line bisect that angle and that angle? Yes, it does. It's true. Then the diagonals of a rectangle are equal in length. Yes, that is true. Okay, question B. It says here that ABCD is a parallelogram. Determine with reasons the size of the angles X, Y, and Z below. All right. So because this is a parallelogram, I know that this side will be parallel to this side. This side will be parallel to that side. Also that these lengths are equal. Okay. But what I want to notice here is that this angle plus this angle will be equal to 180. The reason why is because this is parallel to this and we have co-interior. So x minus 15 plus 2x must be equal to 180. And my reason for this, co-interior angles. Co-interior angles. And remember, state which lines were parallel. So it was AD parallel BC. So what do we get here? We get 3x is equal to 195. Divide 3 by 3 and we get x is equal to 65. So if that is 65, then 65 minus 15, we get that this is 50. If that's 65, then 2 times 65 will give us 130. Right, so next one I can say is y is equal to 50. Okay, and the reason for that, because this is a palm, opposite angles are equal. If this is 130, then that's 130. Z is equal to 130, and it's for the same reason. Opposite angles of palm equal. All right, going on to question 4. Question 4 is saying ACB ACB is 66, as shown below. Determine with reasons angle E, this one over here. Okay, so I just want to see here, this is 90. Then we can work out what A is. Okay, so angle B will be equal to 90 degrees. And my reason for that is angle in a semicircle. Okay, then I can work what angle A is. Angle A will be equal to 180 minus 90 minus 66. And that's because angles in a triangle. Okay, so we get angle A is equal to 24. Okay, so that means that angle E is equal to 24 because it's angles in the same segment. Remember, make your bow tie. Okay. Then question 5. It's saying here, if O is the center of the circle, NKL is 30. So this is 30 degrees. Okay. Determine with reasons the size of B, which is over here, if NK, this whole line here, this line here, NK is a tangent to the circle MJKL. Right, so I know that this angle here will be 30 because it's tan chord theorem. This here will be 90. Okay, angles in a semicircle. Then I can work out what this angle is, and then I can work out what that angle is. Okay, so the first thing I'm going to do is I'm going to say that M2 is equal to 30 degrees, and my reason for that is tan chord theorem. Okay, then K2 is equal to 90 degrees, and that is angle in a semicircle. Okay, now I can work out what L1 is. L1 would be equal to 180 minus 90 minus 30. And that is because angles in a triangle. Okay, so we get here 60. Okay, now if that is 60, and because MJKL are vertices on the circumference of a circle, that means that this is a